all the information. I quickly just want to go, we've still got a few minutes left, so I quickly want to go to the national power grid. And why I want to go to the national power grid is because this is a very controversial topic in our country because of Eskom and things like that. So I'm just briefly going to explain to you how our power grid works, and that you can see once again the step up and the stepping down. Right, in South Africa, most of our power stations, or all our power stations, generate alternating current, okay? And how they generate alternating current is by burning coal. Here's my picture. That coal is burnt. It releases steam. The steam turns a turbine, which causes the generation of the electricity, right? And at this point, we have a transformer, right? Now, it is generated at a certain voltage, and then what happens in this transformer, we use a step-up transformer. In other words, it is actually going to go in at a certain voltage, and it's going to come out at a higher voltage. Right. And why that is going to happen, if I can just explain to you roughly, this is what happens with your transformer. You have an iron core, and then it has a certain amount of coils. It has a primary coil and a secondary coil. If you want to step it up, your secondary coil will have more windings. Right. So what's going to happen in this case is it wants to be stepped up, so there are going to be more windings here. Right. And what happens at this point is they step it up quite a lot. So now it's stepped up to approximately 250 kilovolts. Right. Across all these power lines in our countries, right, it is stepped up. Okay. Then it's going to get to a substation, and at a substation, now they are going to step it down. Right. They're going to step it down so the municipality can actually be working with it, and it can actually be transported that way. Right. So now they're going to use what we refer to a step down transformer. And your step down, what's going to happen is your secondary coil now has less turnings than your primary coil. It normally gets stepped down to around about 13 kilovolts, right? And then lastly, just before it gets to your house over here, it gets stepped down even further to 240 volts, right? RMS, I think, is about 220, right? And now it goes into your house, okay? If you now have a laptop over here, there's your laptop, right? Then you will see your laptop is connected to a charger, and then it's plugged in, okay? Right, now this also is basically a transformer as well. It's going to step it down even further to about 12 volts. Okay. Now, this is one of the reasons why in our country we sometimes buy appliances that don't work. Right, so you get to a place, they're selling something really, really cheap. You think to yourself, yes, I'm going to buy this TV. It's a great bargain. But it will not work on our voltage, right, because of the different frequencies and things like that. And that is why we have so many of what we call grey products in our country. And normally once you've bought it, when you go back, the person's missing, so you can't return it. Okay, and it has to do with various things like this. Right. I just want to read through this so that you can see exactly what I'm saying here. I unfortunately don't have these notes, but I'll try and get them onto the system for you during the time. Right. Our country is generated by alternating current. Because we have to transmit this current over large distances, we convert it to high voltages. Right. Because high voltages mean lower current, and that means we have less power lost by heating. Okay, because remember, copper wire is not an ohmic resistor, right? So there is going to be hot loss. Then before the electricity reaches our homes, our schools, or our factories, it's transformed again to lower voltage so that it's more convenient for us to use. The network of high voltage transmission lines linking the power stations and the electrical substations, it is transformed to a much higher voltage. Right, and that where it's changed is known as our national power grid. When you hear on TV that the power grid is under strain, please turn off things, then this is what they are referring to. Right. The network makes it possible for electricity to be transmitted over large distances, and the electricity can be sent to areas far from the natural resources, far from places where there are natural resources to generate it. Right. And this is very, very important, people, because us here in the Free State, we'd have a little bit of a problem. We don't have coal locally, so we'd have to get our coal from everywhere. So now, instead of transporting the coal, they are actually transporting the electricity. Right, and then we get our distribution network, according to which it is distributed. Right, Matrix, I hope you have everything. I have a little summary here again, but I think we've made so many summaries, but let's just go through a quick summary again. Right, electrodynamics. Right, what is electrodynamics? It's basically where electricity and magnetism is linked. Right, and because of this, you get an electromagnetic force. And remember that electromagnetic force is at right angles to the current. Right, then we have two types that we're working with. We're going to work with electrical current to mechanical. I hope you know what that is. Right, that is a motor. Eh? And then we're going to have mechanical to electrical. That is a generator. Right, and then okay, let's quickly have a look. Yeah. Remember, when we have electrical energy to mechanical energy, it's referred to as a motor. Yeah, we call it the motor effect. And what happens with a motor, we have current, which is supplied, and then we get a force. And remember, that force is the movement. And remember, how would you determine the direction of the movement? By the left-hand rule. Right, okay, by the left-hand rule. Right, the motor effect. Right, what has happened now? We have a power source. We have a power source for a motor, and then it is converted to kinetic energy. And as I've just said to you, we will use Fleming's left-hand rule. Right. Remember, with the left-hand rule, I just used the acronym FBI, FBI. There are a whole lot of others. I just find my learners remember this. Right. B meaning my my magnetic field. And remember, my magnetic field is north to south. So my knuckle is at north. Right. And can you see on this little slide, they say you must first determine the field, and then you do the current, and then you will know the thrust. Okay, that's maybe a good learning tool to remember. Right, remember, I've mentioned this to you people as well. Into the page, right, and out of. You need to find a way to remember that. I also struggle to remember that. Right, and now we get mechanical to electrical. This is called induction, and we also once again have a force, and this force is supplied, and from that we will get an induced current. Okay, and when we have an induced current, you are going to use the right-hand rule. Right, so to find out directions here, we will use the right-hand rule when we have an induced current. Right, then we need to know this turning part is called the armature. That is the part that moves, right? This is a generator. How do we know it's a generator? Because there's no power supply. There's also an AC generator. How do I know it's an AC generator? Because it has slip rings. Right, okay. And then what is important to remember, you must make sure you have the right hand, and you must start with a field, your wrist, which is the easiest part. So what they're saying to me there is start with your electric field. Always first find your electric field. And then from your electric field, you can turn your wrist, because then your current, if your current's moving away from you, you will point away from you. If it's moving to you, you will point to you. Right. Matrix, I hope that I have given you enough information here. This work, I must be honest with you, is learning work. And learners who do badly in electrodynamics are not doing their share. So you need to sit down, you need to look exactly what you need to know in electrodynamics, you need to do a few exercises, and you need to remember that everything that applied to electricity also applies in electrodynamics. And when I say everything, I mean your formulas that you use. Like, for example, your V is equal to IR and things like that. The only difference is you're going to work with IRMS and with VRMS, right? I hope that you understand this work, that you know the difference between a motor and a generator. Make sure that you know the definitions. Make sure that you can identify which is which. Make sure you know which graph, remember. And remember, when they give you a graph, you often need to use some of those values. You need to read them off the graph. Right. I hope you are going to do really well in electrodynamics, and I will be seeing you people again.